Sodium hypochlorite, or common household bleach, is a liquid antimicrobial agent that is an effective sporicidal disinfectant against Bacillus anthracis, or anthrax. Research has shown that when modified, a bleach solution is effective in achieving up to a 6 to 7 log reduction in anthrax spores when applied to hard, non-porous surfaces that stay wetted with the solution for up to 60 minutes. Exact contact time will be determined by removal action plan. Hard, non-porous surfaces are defined as any surface that does not absorb or retain water. The bleach must be adjusted to a pH of 7, with the concentration of chlorine at approximately 5,250 to 6,500 parts per million. Acetic acid or common white vinegar can be used to adjust the pH, and water is used to yield the proper concentration of chlorine. The pH-amended bleach solution needs to contact the surface for up to 60 minutes to be effective. Although not proven in a laboratory or stated on the label, some field applications have shown that a pH-amended bleach solution can be effective on some porous surfaces such as concrete or painted wood. Porous materials are defined as materials that absorb and retain water in pores and within the materials themselves. Household bleach is available at most grocery stores and is a low-cost treatment due to its availability and low-tech application techniques. To use bleach as a disinfectant for Bacillus anthracis, a special exemption is required as per US EPA. Please contact US EPA's NDT for more information. Personal protective equipment, or PPE, required for the mixing of bleach and vinegar is straightforward. Mixing should take place in a controlled, well-ventilated area away from direct sunlight. Protective clothing along with heavy rubber gloves and splash protection for the eyes is necessary. To minimize exposure to chlorine gas, a respirator with combo cartridge or equivalent is also suggested for mixing. The agent being decontaminated dictates the PPE required for the application of pH-amended bleach solution. In the case of anthrax, modified level C PPE using an air purifying respirator or powered air purifying respirator, or level B PPE will be worn as deemed necessary by the site-specific safety and health plan. pH-amended bleach solution has a number of advantages for the decontamination of anthrax. It's readily available in large quantities at low cost. It's effective on non-porous surfaces, and some field applications show positive results on some porous surfaces. It's fast-acting, with up to a 60-minute contact time. Additionally, pH-amended bleach solution can be applied using simple methods such as sprayers, mops, wipes, and other applicators.
We've used it in many applications, 2001 during the first anthrax attacks, as well as some more recent naturally occurring anthrax decontamination events that we participated in. And it's been a fantastic disinfectant, a great biocide for us. So it's been proven effective, and it's just readily available.
The pH-amended bleach solution does have some disadvantages. Bleach is potentially corrosive. Care should be taken to ensure treated materials are appropriate for the application of bleach. Pre-cleaning is required. As per label instructions, a soap and water solution to remove dirt and dust prior to decontamination is recommended. Prior to applying the soap and water solution, a HEPA vacuum can be used to remove gross dust and dirt where applicable. It is also necessary to capture any wash water and dust collected from the HEPA vacuuming. Wash water and the vacuum contents may contain spores and may require treatment prior to disposal. The pH-amended bleach solution is not as effective on porous surfaces. Additional applications of the solution may be needed to increase effectiveness. Bleach discolors certain fabrics and materials and may damage the finish of materials. To be effective, surfaces must remain continuously wetted for up to 60 minutes. This wetting process may require repeated applications to all surfaces being disinfected. Depending on site characteristics and contaminant concentrations, large volumes of bleach and vinegar may be required. The amount of chlorine in the bleach may degrade during prolonged storage. Additionally, the pH-amended bleach solution has a maximum effective shelf life. Household bleach is readily available in retail and industrial containers. Tools and containers for mixing and application are also available through normal supply chains. You will need acetic acid, also known as white vinegar, water, buckets, clean rags, mops, and measuring cups. EPA does not endorse any particular brand of bleach, vinegar, mixing, or application products. Pre-sampling of surfaces should be performed using one of the approved sampling methods to determine the extent of spore contamination. Treating surfaces with bleach is a multi-step process. First, a HEPA vacuum should be used to remove loose materials and residual liquid. HEPA vacuuming can also be used to spot remediate highly contaminated surfaces. HEPA filters have the ability to remove 99.97% of particles greater than or equal to 0.3 microns from the vacuum's exhaust, thereby containing any anthrax spores in the filter or vacuum bag. Next, pre-clean surfaces and walls with water or water and detergent. Response personnel can also use a scrub brush to help penetrate pores. When using a scrub brush, always start at the top and brush down and away to minimize the spread of contamination. For both non-porous and porous applications in a well-ventilated area, prepare a mixture of 1 part 5.25 to 6% bleach, 1 part white vinegar, and 8 parts water. Please note that the PPE worn while mixing the bleach solution is task-dependent, and the PPE required for protection against anthrax exposure may be different. To minimize personnel exposure to chlorine gas, first mix 2 parts water with 1 part bleach. Then add the vinegar, then the remainder of the water. This mixture has a pH near 7, which is critical for the decontamination process. It also generates a hypochlorite solution with a concentration of 5,000 to 6,000 parts per million. Add additional bleach or vinegar as necessary to maintain this concentration and a pH of 7.
For the purposes of the disinfection of Bacillus anthracis, we add vinegar, which is acetic acid, and that balances out the pH to about a pH of 7, but it also creates hypochlorous acid. And that's really the true biocide. It's not the sodium hypochlorite, it's the hypochlorous acid that really inactivates the Bacillus anthracis spores.
For non-porous surfaces, pH-amended bleach solution can be deployed as a misting spray or liquid. These methods can be used to clean non-porous and some porous surfaces and equipment. Treated surfaces must remain in contact with the solution for up to 60 minutes.
And sometimes you have to reapply. If you wipe down a surface, obviously it's going to dry eventually. So you want to put a hardy coating on, and then if you see it drying, you have to reapply it so you have that 60-minute contact time on top of those spores.
If necessary, water can be used to rinse any surface residue. Any residual standing liquid should then be mopped or wiped up. The same treatment can be made on some porous surfaces, such as wood, concrete, and carpet. Depending on the removal action plan, post-treatment sampling may be performed to confirm decontamination effectiveness using one of the approved sampling methods. Retreatment may be required if viable spores are detected during sampling. To minimize exposure to chlorine gas, bleach and vinegar should not be combined together directly. As noted in the How to Use chapter, water should first be added to the bleach, then vinegar, and then the remaining water. Again, to maximize effectiveness, treated surfaces must remain in contact with the pH-amended bleach solution for up to 60 minutes. Repeated applications of the process or adjustments of the process may be necessary to keep contaminated surfaces wet. Also, keep bleach and the pH-amended bleach solution out of ultraviolet light to maintain its limited shelf life. Depending on the manufacturer, bleach generally maintains its designed concentrations for approximately 6 months before effectiveness decreases. Wastewater generated from high concentrated non-pH adjusted bleach should be considered hazardous and handled accordingly. Typically, this type of waste is classified as a D002 corrosive and is transported under Hazardous Material Regulations 49 CFR Parts 171 through 180. pH-amended bleach solutions that have been diluted to 0.5 to 0.6% NaOCl concentration and have the pH adjusted to 7 may be declared non-hazardous. Bleach solutions should be shipped to a waste facility and treated as a waste. Another alternative is to neutralize on site and request permission to release to the POTW. For questions or concerns regarding anything discussed in this video, contact the U.S. EPA National Decontamination Team.